Geometric vectors. Definition. A vector is a quantity that has both magnitude and direction. We usually represent a vector as an arrow pointed in a given direction. It is important to realize that a vector is not necessarily fixed in a certain place, but it does have a certain length and direction. So we got vectors v and u. In v, that arrow is a certain length, that's its magnitude, and it's pointed in a certain direction. Those are the two characteristics that apply to v. And u has a different length and a different direction. So we have v and u. Now if we want to add v and u together, we can do it either way, v plus u or u plus v, but I happen to do v plus u. So I drew vector v in the direction it is in the length, and then I started at the end of the arrowhead of the v, and I applied u in the direction u goes and the length. Now those two together end up for v plus u, or that other vector that starts at the same place v does and ends at the same place u does. So that's v plus u. Now subtraction. Once again I did the v in the v direction, but rather than go in the u direction, I went in the opposite direction because we're adding a negative. That's how we do subtract in algebra, and that's how we do it in vectors. So we went v, and then we went in the negative magnitude and in the opposite direction. So we went backwards, and then we get the v minus u vector, which represents the difference. So to subtract, you go out one vector and then go in the opposite direction for that same magnitude. And then that resultant vector would be the v minus u vector. Multiply by a scalar. So if we want to multiply v, say, by 2, a scalar is just a number. It has only one magnitude. And so we're going to multiply that times v, so we get 2v, and we can see we go v plus another v, and we'll get the resultant vector of 2v. Algebraic vectors. Since vectors have magnitude, length, and direction, but they are not fixed in any position, to be able to deal with vectors better, we will fix them in reference to a given point. We will make the initial starting point for every vector to be the origin, 0, 0, in a rectangular coordinate system. In this way, we'll be able to describe a vector by a single point. We will convert the vector connecting the points 4, 1, and 7, 6 to a standard position. So we want to move that vector that's in the drawing over so that it starts at 0, 0. You can kind of think about how you would do that. How would that change those coordinates if you wanted the first coordinate to be 0, 0 instead of 4, 1? Converting this vector to standard form, we're going to take 7 and subtract 4. That would shift it over so it was on the y-axis, and then the 6 minus 1 would shift it down to the starting point of 0, 0. And now we're going to write it as v equals 3i plus 5j. I is in the x direction, and j is in the y direction. So algebraically, this will be that vector. Now that's the same vector that connects 4, 1, and 7, 6, because you got to remember, it doesn't matter where it is at, it just matters its magnitude and its direction. So our new vector is v equals 3i plus 5j. And then the I and the j algebraically operate as if they were x and y as far as addition and subtraction and multiplying by a scalar, because we still can only do those three functions. We can't multiply vectors. Although later on in Calc 2 you will develop some form of multiplication, in fact 2 forms, but it's not a pure form of multiplication like we think. So we want to find the magnitude of this vector now. The magnitude of v, and we'll use like absolute value signs around v, is equal to the square root of 3 squared plus 5 squared, which is equal to the square root of 34. We get this by using the Pythagorean theorem. I think you could form a little right triangle starting at the origin and go along the x-axis 3 and go up 5. You have a little right triangle. So if you wanted to find the length of v, you could use the Pythagorean theorem and get the square root of 34. That's called the magnitude of v, and it's represented by 2 vertical lines around v. Now we want to get the direction. The direction is the slope. So the slope of this vector is 5/3. So slope will give us direction. The length will give us the magnitude. A unit vector. Now we want a unit vector would be a vector that points in the same direction as our vector, but it has a unit length of only 1. So how do you get that? You take the v vector, 3i plus 5j, and divide it by the magnitude, and that's the square root of 34. So you're going to get the unit vector that corresponds with vector v to be 3 divided by the square root of 34i plus 5 divided by the square root of 34j. Now the magnitude of this is actually 1. That's its name, unit. 1 unit vector. It's pointing in the same direction, but it has a length of 1. Note the magnitude of the unit vector is 1 and has the same direction as the original vector.